Hi everyone. So today we are going to solve this question. So this is the problem of the day for today, and you can see this is an easy question, and yeah, I have solved this question. Okay. So let's see what the question says. The question says that we are given a positive integer, and we have to check if it is having alternating bits or not, right? And what does that mean? That means let's say we have given 5 as the integer. So 5 convert it into the bitwise uh, into binary representation. So 5 is 1 1, and you can see that each bit alternating bit is different with each other. Similarly for 7 you can see that the alternating bits are different, 1 1 sorry, are equal, 1 1 1. So if it is 1 1 1, that means it's false, right? If it is not alternating, the bits are not alternating, that means return false. If it is alternating, return true. Similarly for 11 you can see that till here it's alternating, but after that we get that 1 and 1 both are the adjacent bits are similar, so in this case we'll return false, right? So the intuition to this question is very simple. Let's take the example of 5. So when is equal to 5, so what we'll do, the approach is very simple. So what we'll do, will convert it into binary representation. So it's very simple. How do we convert into a binary representation? We'll divide the number by 2. So in each, let's say we'll take a while loop, and in each while loop we'll divide the number by 2, and each iteration will take the remainder, and that remainder is the binary representation, and we'll just concatenate each remainders of each step, right? So let's say in the first iteration what we'll do, 5 by 2, 5 modulo 2 will get 1. Okay, and 5 will be converted to 5 by 2, which is equal to 1, right? So this is our first answer. Now in the next step, 5 by 2 we did, so 5 becomes 1, right? 5 by 2, sorry, 5 becomes 2. Why? 5 by 2, 2 times will go 5, right? 2 twos are 4, and the remainder becomes 1, and the quotient is 2. So the new number is 2, right? And the quotient and the remainder is 1, and this remainder is our first bit, right, of the binary representation. Just a second. Yeah, sorry. So hmm. So we have this. So in the next iteration what we'll do, n becomes 2, right? So n modulo 2 will, what we'll get, so 2 modulo 2 will get 0, simple. And this is our next bit in the binary representation. And what n becomes, n means 2 by 2, so it goes one time, right? So n is equal to 1 in the next iteration. Now what we'll do, 1 modulo 2 means 1 modulo, sorry, 1 modulo 2, it will be 0, right? And what n becomes, so 1 by 2 will be 0, right? Sorry, this will be 1, because remainder of 1 when we divide 1 by 2 is 1. Okay, in 0 times we are getting, right? And the number becomes 0. So whenever the number, okay, the number becomes 0, so further we cannot divide 0, right? Because we cannot divide 0 by anything else, right? So 0 cannot be divided by any number. So in this case we'll break out of the loop, and in each iteration we are checking the current remainder is it equal to the previous remainder? No. Then go to the next iteration. Again, the current remainder, is it equal to the previous remainder? No. Then, so when it is like, when the remainders are not equal to the previous remainder, we'll just keep on dividing the number, and once the number becomes 0 we'll just break out of the loop, right? And let's say if the remainder is equal to the previous remainder, in let's say here, if we get 0 is equal to previous remainder 0, so immediately we'll just break the loop and we'll return false. I hope the approach is very clear to everyone. So now what we are gonna do, we're just gonna code it up. So I'll take one value, let's say previous remainder in remainder equals to -1, and while true, because why we are taking while true. See, now here we need to check the constraint. So we can see the constraint is of 32 bits to the power 31. So at max we can run till 32 bits, right? So if we run till 32 bits, what will be the time complexity? Time complexity will be big of 1, because we know that at max 32 bits integer we are getting, right? So big of 32, big of 32, 32 is a constant number, so the time complexity will be big of 1. Okay, now why we are taking true? So taking true because we don't know what will be the size of the binary representation. So for 5 we can see it is 101, for 7 we can see it's 111, three bits are there. But for 11 you see 11 it's 4 bits, right? So better to say true whenever the number is 0. Okay, whenever the number becomes a 0, at that time we'll just break the loop, right? I'll show what I meant here. Okay, so now we'll track the current remainder equals to n modulo 2, right? And we'll check if current remainder is equal to previous remainder. So what we'll do here, we'll just return false, okay, because this is a false condition. Else what we'll do, we'll assign the current previous remainder with current remainder value, current rem, right? And we'll change the value of n by 2. Okay, now how we are gonna break the loop? If n is equal to 0, further we cannot divide the value of n, right? So what we'll do here, we'll just break the loop and at last return answer, and we'll take one value, boolean answer is equal to true, right? Let's run this code. Correct. Yeah, you can see the time complexity is the best in this condition. So there are few other ways of solving, but the time complexity will take big of n time here, because see, they're converting the string, converting the array into string integer, sorry, string array. So and each time they're comparing the previous number. So yeah, it will be taking big of n time complexity. Better to go with this approach, I believe. Sorry, not this approach. This approach, right? Yeah. Thanks for watching. I hope the solution is simple and easy to understand.